All right, my name is Brandon Clayton, the Algebra Guy. Today I want to talk to you about simplifying expressions with integers. So at the end of this class, you'll be able to evaluate the problem that you see here. X plus y squared when x is equal to negative 18 and y is equal to 24. So let's get to it. All right, so here are the questions that we want to answer today. How can the addition of integers be modeled using counters? So I want to give you a model using some kind of, we're in internet land, of course, video, so I can't actually have you grab these, but I want to at least give you the idea when it deals with integers. And then talk about how can expressions with integers be simplified and evaluated. All right, so let's start with the models. All right, we're going to model addition and subtraction of negatives with two color counters. We're going to let the blue counter be the positive and the red counter be the negative ones. The reason that this is important is they found that the research is better when starting to talk about negative numbers, since the idea of a negative is not really a natural number or something you deal with just in nature. It's good to start with something that's more tangible. Kids realize what minus is or negatives in the sense of if they had two apples and someone took one away. But how do you grapple with the idea of having a negative number adding a negative number, or some of the combinations of positive and negative? So I want to deal with that using these counters on our screen. So modeling integers. If we have one positive and one negative counter, the value of the pair is going to be 0. Because you got to think about it. You got a plus 1 and a minus 1. You put those together, you get 0. And I'm using these counters as you see here. They form what we call a neutral pair. Sometimes in some classrooms they're called a zero pair, because when you put one plus and one minus together, you get 0. And I just want to make sure I take this point home to be very clear. So if this was a negative 1 and a positive 1, so if you go from if you go back 1 and then you go forward 1, you're going to end up at 0. The same thing is going to happen if you do the same thing with the positive. If you go add 1 and then you take away 1, you end up at 0. So the idea is if you add and subtract the same amount, you're going to be at 0. I know it's redundant and I'm beating a dead horse, hopefully, but I want to make sure we get that, because we're going to use that idea as we answer some of the following questions. So this is what I just illustrated to you here. 1 plus this negative 1 is going to equal a 0. All right, so here let's do some practice real quick. So 5 plus 3. I know you know the answer. You can use your fingers for that one, right? 5 plus 3 is pretty easy to do. But how would you use it with a manipulative, if you will, some counters? So thinking about our counters, we'll draw 5 positive counters plus 3 positive counters, and we'll add all those together. We'll collect those if we were doing it on our tables, and we'll realize we have 8 counters. Now this is a great way to teach young kids just the basics of adding and subtraction, but when you get to integers, it's particularly useful. So let's do our next one. So we got negative 5 plus negative 3. Negative 5 plus negative. There's our negative 5 and our negative 3. And it's going to equal, as you see, the answer. I already showed it. I didn't mean to. But I'm just going to put all my negatives together. So if I had literally physical counters that were red, and I had 5 of them representing negative, 3 representing negative, and I added all those together, I have 8 counters that are negative. So this is a way to kind of think through this idea of negative things coming together. Because I have a lot of students that struggle when you start saying it this way, negative 5 plus negative 3, and everything is jumbled up in their heads. Well, you got negative 5 counters plus another negative 3 counters, and you're going to have negative 8 counters altogether. Now, if you think about it in real life, if you lose $5 and you lose another $3, then you totally lost $8. Or if you lost 5 yards and lost another 3 yards on the next play, you totally lost 8 yards. So those are other ways you can think about it. What about this one, negative 5 plus 3? You want to try this one by yourself, maybe in your head or using counters on your paper. I will pause it and see if you get it. So we got negative 5, right? Plus 3 positive ones. What is that going to give me? So this is a little bit different because now we have different counters that we're combining. How do we deal with this? It's tempting to say this one's 8, 2, -2, -8. What is it? How do we think through this? Well, this is where we're going to go back to our 0 pairs. So we're going to add, when we're adding negatives and positives, in your mind you could think that we're taking a negative counter and adding it to a positive counter. So this negative and that positive is going to give me a 0. So there's no point even counting those anymore. Matter of fact, I can continue to do that as much as I can to get all the zeros out. So I've collected all my 0 pairs. So everywhere you see this yellow circle, these are adding up to 0. So now we can just simply count the remaining ones not circled. And that gives us 2. -2, to be sure. And I want you to notice another thing too, that since we have a bigger negative value, we're going to end up with negative numbers left over. That makes sense, right? So if these were 5 apples and 3 blueberries, and we combined 1 to 1 blueberries and apples, of course we're going to have more apples left because there's more apples to begin with. So you're going to see this pattern continue to come up as we go through here. All right, doing another one. That's 5 plus -3. So there's my 5, positive 5, plus a -3, and I'm going to think of it the same way. I'm going to combine all of my 0 pairs. And now I've got rid of those, I can see what's remaining. See, this all just adds up to 0. And now I just see that these 2 remaining, so I know it's going to equal a +2. So as I've been getting that, I'm hoping that you saw the pattern that was starting to emerge. So 5 plus 3, when they're both are positive, the sum is positive. But if you have a -5 plus -3, or both is negative, the sum is going to be negative. That makes sense if you think about the counters we're using. 3 negative counters plus 5 negative counters, -8 counters. When the signs are the same, the counters would all be the same colors, so we add them. What if they're different? -5 plus 3. Different signs, but you got more negatives, then you're going to get a sum that's negative. Different signs again, but you got more that's positive, you're going to get a sum that's positive. When the signs are different, some counters will make neutral pairs, or what I've been calling 0 pairs, and you're going to subtract them to see what's left. So that's how we've been working through those. All right, let's practice to see if you're getting it. All right, so here's 2 problems. Let's start with the letter A. 19 plus -47. Whoa, so you don't really want to roll out all the counters for this one, do you? No, of course not. But the counters were in place to help model something that we're going to do on a larger scale. But you can't imagine the idea of having 19 positive counters and -47 counters. So what did we just talk about with the pattern? Well, we notice when we add 2 different signs, the bigger sign stays. So this simply becomes 47 minus 19. So we're going to just take 19 away, and whatever that number is still going to remain negative at the end. So let's see if I can do this subtraction. 17, 6, 2, and that's going to be 26. We know that's going to be a -26. Because let me show you again how else you can look at this. So if this were 0, let's show it on the number line. So if that were 0, we said 19, and we're adding a -47. So we're adding negative. So we're actually taking away from this 47. So we have to go 47 units back, all the way back here, and it's going to take us to a -26. So how many units do we have to go back? Well, it says -47 units back. And that gave us to a -26. So 19 here to get to 0, and another, what was that, 26 here. So we went back 19 here, and back another 26. So just want to make sure you can see it multiple ways to get this idea. All right, so we got 2 different signs. What's going to be the sign of the answer? Well, which is bigger? When you're adding, you can do that. Now, multiplying and dividing is a different rule, and we'll get there. But right now, when you're adding, you got -32 counters. You got more positive counters, so we know we're going to have a positive number. So this is really going to be 40 minus 32, which is 8. How do we know it's not going to be what could we say? Negative 72. Well, first we know it's not going to be negative. Well, how do we know it can't be 72? Well, that won't make sense because 32 plus 40 is 72, but negative 32, well, negative 32 is way back here, and we're adding 40. If I add 40 more, well, adding 32 will get me to 0, and I add 8 more to bring me to the 8. So this is a total of adding 40 right here, and that brought me to 8. So another way to see this is I owed negative $32 in my bank account because it was overdrawn. I put in $40. Now I have a balance of 8. All right, let's continue with our practice. Let's simplify this. Negative 42 plus negative 36. Both of the signs when I'm adding are negative, so I'm adding a lot of negative counters. Think about it that way, and adding more negative counters. So this is going to be just adding these two numbers together, 36 and 14. And you know the answer is going to be negative. So 36 and 14 is going to give me 50. So I know the answer is going to be a negative 50. Why? Because both of these are negative. You're just going to get a really big negative number. All right, let's do our next one. And I'm going to encourage you, each problem, please pause and try it yourself, because that's really going to help you to learn the fastest. All right, so PEMDAS tells us to do the parentheses first, do whatever's in here first. So negative 2 plus 7. I know the bigger number is 7, so it's going to be a positive value. So this becomes 7 minus 2, which is just 5. Again, another way to see this is have negative 2 counters plus 7 more. If I could draw that, so let's say these are negatives. I'm gonna keep the same color, and then we had, I guess I'll change, and then we had, 7, 1, 2, 3, 4, 5, 6, 7. So these were all positives. I guess I could just do plus signs, but these were all positives. Well, I know I'm gonna have a 0 pair here, plus and negative, and another 0 pair all the way around here. But these are 0 pairs. So all I have left are these positive 5s, and that's what's going to give me that 5 there. So I just want to make sure you're seeing that, because it's important as we build a foundation, get into negative values, that you have a firm foundation on these. So it just takes a lot of practice. So now this becomes 3 times 5, because that 3 up there, plus negative 5. PEMDAS tells us what to do next. It says parentheses, exponents, multiplication, division, then add the subtraction. Well, we did our parentheses. Now we have no exponents, but we do have multiplying right here. 3 times 5, so that's going to be 15. And now I do my adding and subtracting. Negative 5 plus 15. I know I'm going to have a big positive number, so this answer is going to be positive. It's going to equal 15 minus 5, which is 10. All right, let's do another problem. But this time I want to evaluate. So evaluate means to find the value of this expression when I plug the following values in for x. So what if I put negative 2 in for x? Well, we actually just did that. So this would simply be, instead of x plus 7, this is now going to be a negative 2 here, negative 2 plus 7. Well, negative 2 plus 7 is a 5. And instead of x plus 7 here, I'm going to have a negative 11 in place of x plus 7. Or negative, and I know this value is going to be a negative because the negative is bigger. But it's going to be less negative because we're adding 7 to it. So it was negative 11, and here's a 0. Well, I'm adding 7. 1, 2, 3, 4, 5, 6, 7. Adding, increasing goes this way to the right. And I'm left with, it stops at what number? If I add 7, I think that's going to be 4. Actually, a negative 4, right? It's going to be a negative 4 it stops at. When n is equal to negative 5, let's evaluate the following expressions. So if n is equal to -5, well, instead of n here, we're going to put -5. So that becomes -5 plus 1. I know this is going to be a negative value. It's going to be negative. -5 plus 1 is the same thing as -4. Because we're going to add 1. Again, if I drew it on the number line, it'd be a -5 right here. And I'm increasing it by 1. Increasing goes to the right. So that's a -4 here. You could have also thought about it in counters where that you have negative, 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 and you have a, let's change the color, 1 positive. So these two would cancel out to 0, leaving me with 4 negatives as my answer. What about this? It's negative n. Well, n is -5, so negative, opposite of -5 plus 1. And we know -5 is -5. What's the opposite of -5 right here? It's telling us to do the opposite of what's in here. So that would be a 5 plus 1, and that's pretty easy. It's just going to be 6. Let's do evaluate this one. We're being asked to substitute 2 values in for a and b. So 3, oh, that's not a pretty 3. So let's do 3a plus b. So we're going to input 3. Instead of a, they said let's put 12 here. And instead of b, they said let's make it -30 plus a -30. Well, let's do PEMDAS says and do multiplying and division first. So 3 times 12 is 36 plus a -30. Well, now we have a bigger positive number than negative, so I know this is going to be a positive something, and we're simply subtracting at this point. 36 minus 30 is just 6. Again, showing you a different way just to give you the idea. 36 adding a -30, so you're really taking away 30. 6. So you didn't take, if you took away 36, it would have been at 0, but they didn't take away a big enough number. It would have had to have been bigger than 36 to get to the negatives. So that's why we stopped there. All right, and our last problem, the one that I introduced it with, evaluate this one. X is -18 and y is -24. So x, instead of x here, we're going to put -18 plus y is 24, and all that squared. Again, PEMDAS is what I'm using to figure out which do I do first, because there's a few operations here. There's a plus, there's a squared, and there's a parentheses. So I'm going to do the parentheses first. So whatever's in here, we're going to put together. There is an exponent, but we got to take care of what's in here first. So let's do -18 plus 24. 24 is bigger than 18, so I know it's going to be positive. So we're really doing 24 minus 18. So that is simply 6. So now I'm left with just this being 6 squared. We do our exponent first. 6 squared is the same thing as 6 times 6. And 6 times 6 is 36. And I am done with that problem. Congratulations on making it through that. Did we answer our question? How can the addition of integers be modeled using counters? We showed that positive and negative counters and how you can make 0 pairs from those. How can you express with integers being simplified and evaluated? So we both simplified some expressions and we evaluated by plugging in values for x and solving it with plus and negative, positive and negative integers. Thank you for tuning in. I hope that was helpful. My name is Brandon Clayton, the Algebra Guy, and I will see you next lesson.